Alright, geometry, our final in-class lesson on Standard 7, which are proofs related to parallel lines. Okay, so we have so far covered, out of the four kinds of two-column proofs, we've covered the congruent angles using transitive property given parallel lines, and we've done the parallel lines using the transitive property and a converse. So today on in-class 31, we're going to look at being able to do two-column proofs for congruent triangles if you're given parallel lines, and parallel lines using congruent triangles and a converse. Okay, so let's look at a few reminders here to start with. To prove triangles are congruent, what are all of our possibilities? So a reminder that we have side, side, side. Okay, I'm going to abbreviate these side, side, side. Okay, we have angle, side, angle. Okay, we have side, angle, side. And we have angle, angle, side. Okay, the other one we have is the hypotenuse line, HL. Okay, and a reminder that after triangles are congruent, we can use the corresponding parts to congruent triangles are congruent, CP, to show that corresponding sides or angles are congruent. Okay, so be on the lookout for a couple of consistent theorems that come up, or the vertical angles theorem. Okay, and also the reflexive property. Okay, so let's apply some of these proofs here. Okay, given AB is parallel to CD to start with. Okay, AB is parallel to CD. Okay, so of course we start with what's given, AB parallel to CD. Okay, and that's given. So AB parallel to CD is given. Okay, so if those are parallel, we also know that angle ABD is congruent to angle CDB. Excuse me. Right, because this would be a transversal through my parallel lines, so those would be alternate interior angles. Excuse me. Okay, we are also given angle A is congruent to angle C. Anything else we know regarding these two triangles, I should say? We know that this BD is congruent to DB, right? And that is our reflexive property, right? It has to be equal to itself. It's the same segment. Okay, so I have angle, angle, side that says triangle ABD is congruent to triangle CDB. Okay, keep the end in mind, right? What are we trying to do? We're trying to prove the triangles are congruent. To do that, we needed to use one of our 5 options here. Okay, next one, we're going to try to prove the two triangles are congruent again. Okay, so start with being given the two parallels. Okay, this time BC is parallel to DA. Okay. And again, if it helps, you want to go down here and put your AD congruent to CB. Okay, AD is congruent to BC. That is also a given. Okay, what else do we know from being given that BC and AD? Okay, this would be like our transversal through here, right? So we can say ADB, angle ADB, is congruent to angle CBD, right? ADB is congruent to CBD. Okay, and that would be our alternate interior angles theorem. Okay, and then we had our given. Next, I can say BD is congruent to DB by our reflexive property, right? So I have a side, angle, side, side, angle, side. So based on side, angle, side, I can say triangle ABD is congruent to triangle CDB. Okay, good work. Okay, next page, we've got 4 more examples. Again, if you're watching the video, that means at any point you can pause the video and give it a try on your own, catch up on notes, whatever you need to do. Okay, AD is parallel to EC. Okay, and again, if I have this transversal, I can say I have alternate interior angles here. Angle A is congruent to angle E. Okay, and you can list it as DAB, CB, that's fine. Okay. Next, I'm told B is midpoint of DC. B is the midpoint of DC. That's given to me. And what that tells me is that BD is congruent to BC. BC and BD are congruent by definition of midpoint. Okay, next I can say angle ABD is congruent to angle EBC. That's the vertical angles theorem. Okay, again, look at what we're trying to prove, that the two sides are congruent, two segments, okay? So I can now say that the triangles are congruent by angle, angle, side. Okay, but that's not what I'm trying to prove here. Because my triangles are congruent, I can now say the corresponding sides of AD and EC are congruent by CP, CT, C. Corresponding parts of congruent triangles are congruent. Okay. Next, BD and BC are congruent. BD and BC. And again, we're trying to, this time we're going to prove two are parallel. Okay. So BD is congruent to BC is given. Okay. Next, B is midpoint of AE is given. So if B is the midpoint of AE, that means I know that I've got AB is congruent to EB by definition of midpoint. Okay, so that's everything given. Next, I can say angle ABD is congruent to angle EBC because there are vertical angles. Okay, vertical angles theorem. Okay, so at this point I can say side angle side, side angle side. Therefore my triangles are congruent. Okay, if my triangles are congruent, I can then say that angle, let's see, I'm trying to prove that AD and CE are parallel, right? So that would be like this is the transversal. So since my triangles are congruent, I could say that angle EA is congruent to angle E. Sorry. CPCTC is the reason, right? Corresponding parts to congruent triangles are congruent once the triangles are congruent. And because angle A and E are congruent, I can say AD is parallel to EC by the alternate interior angles converse. Great work. That's, I think, about as hard as it's going to get right there for you, this standard. Okay, so being able to go this far gets you to the level 4. So when you have triangles, if you can prove the triangles are congruent, you can use one of the converse theorems to get parallel lines. All right, next. We've got EF parallel to GH. Okay. So that would be like saying my transversal is FH here. Okay. So that would be like saying EFH and GHF are alternate interior angles. Angle EFH is congruent to angle GHF. Alternate interior angles theorem. Okay, so far. Next, I'm given FG is parallel to HE. Use a different color here. FG is parallel to this side. Again, the transversal going through here, that's given. The transversal going through says alternate interior angles would be these two. So EHF and GFH, these two. So angle EHF is congruent to angle GFH. And that is alternate interior angles theorem, based on being given the two parallel lines there. Okay, next I can say that segment FH is congruent to segment HF by the reflexive property. Again, it's its own segment. So I have angle side angle. And the triangle EHF is congruent to triangle GFH, right? Angle side angle. Okay, trying to prove segment EF is congruent to GH. We just did that because EF and GH are part of the triangle, and we can say CPCTC is our reason for that. One step at a time. Okay, when you're given something, what can you find from that? What can you use that will be helpful from it? Okay, and our last one. FG parallel to HE is given. FG parallel to HE, okay? So this would be like my transversal then. Okay, so I can then say GFH is congruent to EHF, alternate interior angles. Okay. Next, I'm given angle G is congruent to angle E. We'll put 2 marks there, G and E I'm given. Okay. I also know that FH is congruent to HF, or FH, by the reflexive property. Okay, keep in mind we're going to try to prove parallel. Okay, so proving parallel means I'm going to at some point use the converse. Okay, so I've got a parallel line, congruent. So step 5, I would say I have angle side. So my triangles are congruent. GFH is congruent to triangle EHF by angle side. Okay, I'm trying to prove EF is parallel to GH. So EF is parallel to GH. Okay, so if this is a transversal, then I can see if here's my transversal through the parallel lines I'm trying to prove, my alternate interior angles would be these two. Okay, so because of that, I can say angle EFH is congruent to angle GHF by CPCTC, right? Corresponding parts to corresponding triangles are congruent. So, because those angles are alternate interior angles, if my two lines are parallel here, I can then say EF is parallel to GH. One step at a time, okay? But once you do practice these, you're going to see there is definitely a pattern. There's obviously some things that change slightly, and of course that matters if you're proving 2 congruent segments versus 2 parallel segments, okay? Practice, 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 and know your terminology, your theorems, postulates, definitions. Have to know those, okay? So go ahead and do your homework 31. This is the last in-class day. Homework 32 will be a review before you have your standard 7 check.